Okay, so we will be learning about HW equilibrium, or in other words, Hardy-Weinberg equilibrium. This deals with the alleles and the homozygotes, heterozygotes. Let me show you the equations, formulas of this Hardy-Weinberg equilibrium. So firstly, we denote allele as a single expression A or A. The capital letter represents the dominant genes, and the small one, or the small one, actually represents the recessive genes. Okay. On the other hand, if you say homozygotes are the combination of similar genes, right? Like AA and AA. Okay. Homo means similar, and the hetero will be different, heterozygotes. Zygotes are representation of two alleles together. The zygotes will be the responsible for a trait. Okay. The homozygotes will be same. Both traits will be the traits will be either dominant or either neither recessive. Okay. And the heterozygotes will be AA. One will be dominant and other will be non-dominant or recessive, so that will result into the dominant part. So you are understanding that if we create the combinations with two alleles, we will get four possible combinations, right? AA, by putting A, you will be getting A and two A's. So the dominant will be AA. Okay. Or the dominant traits will be observed at these and these type of zygotes, in these types of zygotes, right? AA and AA, these will result into the dominant trait, and the recessive traits will be A. So you are seeing here the dominant trait, or the possibility of having dominant trait, is greater than the recessive trait here. So if we denote A as the P, and if we denote A as the Q, this is for mathematical modeling. The possibility to have the dominant gene, the possibility to have recessive gene in an allele. Okay. So the probability will be P for dominant, the probability will be Q for recessive. So if someone asks what is the probability of dominant one, so dominant trait, what is the possibility of dominant trait? That will be AA twice AA. Did you get my point? Because these two part will be dominant, right? These two part will be dominant, and this one will also be dominant. So three possible traits that will be dominant. So AA plus 2AA is equals to the dominant possibility, right? Okay. And AA will be the recessive possibility. Okay. So what will be this one? AA will be P into P plus 2 into P into Q, right? Because the small one will be Q from this one. So we can write it P square plus 2PQ. And for this one, recessive one, AA, so we can write QQ is equals to Q square it is for recessive one, and that will be for dominant one. The possibility of dominance, the possibility of recessive one. I think that's clear. So the dominant traits will be p square plus 2pq percentage, and the recessive trait so will be q square, right? This is the possibility of traits. I am not talking about the frequency of alleles. The frequency of alleles will be p and q. This is the p and q will be the frequency of alleles, right? But this is the possibility of having dominant traits, and this is the possibility of having recessive traits in a Hardy-Weinberg equilibrium. Okay, so in a zygote there will either be p or neither be q. There is no other possibility to happen, or the frequency of p plus q will be 1. Did you get my point? The probability of having p plus q is equals to 1, because those alleles will be created by either p neither q. There is no other possibilities. So p and addition of p and q will be always 1, or 100%. The combination will be 100%. So the frequency of p and q will be 100%. And the possibility of dominant traits is p square plus 2pq plus q square. This is the possibility of dominant traits, and this is the possibility of recessive traits, is equals to will be 1. So this is first formula, this is second formula, right? Okay, so let's do a math. The first math is an allele for white wool is W, capital letter W, and the another one is small w. There is a sample of 900 sheep. 891 are dominant because they are white, and the 9 are black. So we can say W is the trait. I am repeating again, the black and white is the trait, not the allele itself. Allele just represents A or A, single words, if you just want to remember in a simpler way. And the traits are represents as A and A, small a. This is the traits. Be careful. So here WW, the recessive traits are only 9. The outcome of recessive traits are only 9 because only 9 were black, and the white or the dominant traits are 891. Did you get my point? WW, if WW is 9, so Q square will be 9 by 900. This is the possibility. That's why we are dividing by 900 in here. So that results into 0.01 maybe. And the result comes out that the Q square is 0.01. So the Q is only 0.1. This is the frequency of allele, because you have been asked to find out the allelic frequency. You have to find the allelic frequency. This is the frequency of small w. What is the frequency, allelic frequency of small w? The allelic frequency of P will be 1 minus 0.1, because P plus Q is equals to 1. So the Q is found from the equations. So the P will be 0.9. Did you get my point here? This math is very clear, right? Okay, let's go to another math. In a population of So here also I have been told that the frequency of recessive homozygous genotype of a certain trait recessive. So you are already been told to consider the small ones, right? So the recessive homozygote, there is a dominant part, both are dominant, one is dominant and one is recessive, but this will also result into dominant traits. But here both alleles are recessive and will also result the recessive trait, right? So you have been told about the recessive traits, the AA, okay, small AA. The frequency has been told to you. So the frequency of trait, not frequency of allele, the frequency of trait has been given. The frequency of trait and the possibility or probability of trait is the same, right? That q square is 0.09. Did you get my point? The q will be then 0.3, then q will be 0.3, and you have been asked to calculate the percentage of individual homozygous for the dominant allele. Okay, so you have been asked to homozygous dominant. Listen carefully. This is homozygous dominant. Homozygous dominant. This is a homozygous dominant. AA. This is called homozygous, and this is hetero. Hetero is called AA, and AA, these are homozygous. Homozygous dominant it is, and homozygous recessive it is, and heterozygous is this one. But the heterozygous will always result the dominant traits. Be careful, okay? So you have found q. Now you have to find out the calculate the percent. So you have to find out the p square, because they are asking for AA. AA refers to the p square. A and A refers to the 2pq, and a small a refers to the q square. You know the thing, right? From the boxes, see there is 2pq. AA repeats twice, so we are saying pq and pq plus pq, 2pq is this one, right? And AA is p square, one box for that one. Small AA is q square. Okay, so you have to find out the p square. So you have found already q, so p will be 0.7, subtracting from 1 minus 0.3, so p square will be 0.7 square, or 0.49 maybe, 0.049 or 0.49 maybe. Okay, is it clear to you? Oh, okay, 0.49 means 49%, right? You have to calculate the percentage in here. You know the thing. Okay, so let's take a look at 4 number math. 38% of the individuals are recessive homozygotes for a certain trait. So recessive homozygote, recessive and homozygote, that means AA, right? So the q square is 0.38, 38%. So you have to find the total population is 14,500. We have to find out the percentage of homozygous dominant. Homozygous means AA or small AA. Homozygous dominant, so dominant will be AA individuals, and heterozygous individuals, homozygous recessive individuals. This was told to find out the homozygous dominant individuals and heterozygous individuals. So you have to find out the AA possibilities. You also have to find out the AA for the percentage of difference. Okay, so let's do it. P square will be responsible for AA, right? So what's that? You have been given with Q, so Q square, so Q is root over 0.38. That is 0.616. So P will be 1 minus 0.616 is equals to 0.3835, right? Okay, so the P square will be 0.3835 square. That will be 0.147. So the population of homozygous dominant will be 0.147 or 0.15, that has been represented in the answer sheet. Okay, 14,500 total into 14,500, that is about 2,133 persons. Okay, and the heterozygous is PQ. So P and Q is equals to 0.3835 into 0.616 is equals to 0.2362. So the heterozygous dominant will be 0.2362 into 14,500 people is equals to 3,425 peoples. Okay, this is very round figure that can be varied in as per the result, but the process is this one. Okay, let's see the 5-number answer. RH positive and RH negative. So here it is told that dominant allele is RH plus and the recessive allele is RH. This is the alleles, and this will result into us, that means RH 2 into this one plus RH, this will be the that means the P square plus 2PQ plus Q square, RH, the Q square is equals to 1, right? Did you get my point in here? Okay, so it has been told that (160) out of 200 are RH positive. So P square, you have to find out the P and Q, frequency of both alleles. You have been given with the values of RH positive. So P square plus 2PQ is equals to 160 by 200. That is given in here. So what can I do? Okay, so if this is around 0.8 maybe, so Q square will be 0.2 because we know P square plus 2PQ plus Q square is equals to 1. We know the thing, right? So if we know the P square plus 2PQ is 0.8, then Q square will be 0.2. So q square is 0.2, so q will be root over 0.2, that is 0.447, that means 45% maybe, and the p will be 55%, right?